All right, so for those of you who aren't on the dev team, the whole purpose of this it's our first step in decoding hieroglyphics and potentially old manuscripts. This project was all about identifying, isolating individual lines of text, or maybe not text, but glyphs, and essentially outlining them in a rectangular area so we can use that data, that area, to feed it into the system later, because in order to successfully decode hieroglyphics, we have to get it into essentially an English sentence. In order to do that, you have to detect areas like rows, lines of text or glyphs, and then detect the glyphs. And then you can combine those two things to actually serialize them into hopefully a readable sentence. So we've got two teams, Bravo and Charlie. So how'd you guys like working on the teams? Yeah?
Yeah.
Okay, so should we use something like that moving forward? Maybe? Perhaps.
I think it helps.
Okay, you're not so sure, Matt?
I don't know. I'm torn between like the financial motivation was definitely there pushing, but at the same time, I also feel like it might help to have more heads on the same thing, but then also makes problems with like committing stuff and working on different. I don't know.
Yeah.
So.
Yeah, okay. Well, we might, for some things, we might use contests like this. We might move to a more collaborative competition type thing where, it's not so dog eat dog, but I kind of like the dog eat dog and see you guys scramble and try to keep secrets from everybody. Okay, so I think some of you know this. I actually shadowed you guys and I wrote my own code. So I'm Team Delta, so I'll show you my code. But let's go over the team's individual results. So this is Team Charlie first. We've got a nice little letter. Did well, you outlined everything, so you caught that, nice job. This is your columns? And you maybe do twice as much work because you had two algorithms you wanted me to run, sugar and columns. So this is columns,
That's cheating.
this is sugar.
So sugar, actually, do you have the page example open by chance?
No,
Okay.
I didn't open that,
Even
but
for this one, you can kind of see. So what we wanted to do with sugar was kind of like, you see on the other example, it catches the tops and bottoms of a letter, and they don't overhang into the next box. But for sugar, when there's overlapping, we wanted to catch those boxes. So if a G hangs into the next box, we wanted to catch the entire G and put it in its own box. So it catches the entire line, and it doesn't condense boxes.
okay, nice idea. What's with this crap hanging off here?
Because of columns.
Okay, I don't see a column there. I don't see a column there. All right, so next one. Let's see. Let's go over to Team Bravo. Actually, Team Bravo, you have for that one. Did a nice job. You got everything. Congratulations. And I did as well. I did cut some of this stuff, some of the rows into. With the column cutting algorithm, it did chop that up a little bit. All right, so that was sugar. This is the next test right here. This is who's this?
Bravo.
This is Bravo. So you did introduction. You caught everything. It looks like. This is weird. Why is there a centroid right there? That means there's a area someplace, like a ghost area. I'll have to take a look at that. But actually, it looks like. We don't have centroids down here, which is kind of weird. Actually, I know what that problem. It's a problem in my code. I fixed it at home, so I have an advantage over you guys. So, yeah.
You would remove the centroids from the bottom two, and then it would and then add some at the end. My guess is that might be what that floating one is, but I don't know for sure.
Yeah, so that I discovered that issue. All right, so let's see how Team Charlie did. Did I just close a bunch of windows? This is Bravo. Where is Charlie? Cancel.
That's pretty good, Dilbert.
It's a pretty good Dilbert. All right, whose is this? That's me. All right. Charlie.
Well, that's the old.
That's the old one.
There it is.
There we go. Columns did okay. Nice job. Sugar still has that crap hanging off. It's got some other areas here too. So I think the columns algorithm is better. All right, so Dilbert, this is This is going to throw everybody off because you don't know how to process this stuff. It's a lot of weird stuff in here. You're not cutting rows. What happened to that?
Because if you look on the right side of the image, you see that black stuff that's hanging off the right side,
Yeah.
way on the edge of the
Yep.
of the text. So it considers that a continuous point. So something we were trying to do is write a recursive algorithm for destroying like edges of a pages that show up as white on Canny, but it's really hard to write, so we didn't get it done.
So this is your columns algorithm. Why didn't you cut columns right here?
In Candy, it shows up as a big white or a big black image. For some reason, I don't know why. I'm not cutting columns right there.
All right, let's take a look at Bravo. This is Bravo. Nice job. Good, you got a solid one up here, that's good. And you got the areas, that's good. So, see what I did. I got that. I got them too on this one. I went a little bit further and I went inside of the Dilbert. Try to cut the rows of text and isolate them. All right, so far you guys are doing good. All right, so, Team Charlie, the sugar. You gotta get rid of sugar. There's just like too much crap hanging off there. All right, so this one looks good.
We think they have the second line.
Yeah,
Or the third
a
line.
white rabbit.
Oh, yeah.
have it
Good eye, opposing team. All right, so we got to remember this. This is one check mark against so you can at the end of this, I'll give you one option. You can choose between columns or sugar as the best one. Sugar is performing really terribly, so I would not select sugar as the one you want to go with. But this is columns right now, and you missed the line. So that's
Where?
yeah. Okay. All right. So let's see how Bravo did. Bravo. Did okay on this one. Nice job.
Oh shit, we got that too.
Was this is the one that they missed? You got everything here.
The bot box.
No, I got them all. I don't count half lines of text.
One at the bottom that's cut off.
Yeah.
It's too skinny.
It could be that could be a small improvement, but it's not a big deal. Sugar is not doing so hot. All right, so here's your algorithm. Missing some rows here. No area even around this. Okay.
Is that sugar too?
This is columns,
Oh.
right? Yeah, columns. You're missing the first full line up here and a couple lines in here. Okay.
I mean, now we do.
We know.
Sugar is not performing well at all. All right. This is a simple one. You got that. Let's go back over here. Nice job.
So when you cut columns, do you cut it right down the middle of the text though?
What do you mean, like down the middle?
Yeah, you guys didn't cut columns here.
Yeah.
So I guess there's no harm in explaining how we cut columns kind of now. So we go through the image again, top to bottom, and we look for like continuous white space that is like, and then we stop when we get either to like the bottom of the image or like enough black that it considers it like another paragraph.
Okay. How about we circle back at the end, and each team will describe the general algorithm stuff right here. Yeah. So this is who is this, Bravo or Charlie?
That's
Bravo. So this is non-optimal. I would say that's an incorrect result right there, because you're chopping something into a column that's not a column, because you're taking the assumption that it goes the whole page length, which is a bad assumption.
Well, not the page, like it goes until that black bar and then it stops.
Yeah, but it didn't. Should have stopped higher. So that's an error. No matter how you try to justify it, it's an error. It didn't break it. Okay, so next one. What is this? Sugar. Jesus. We're not going with sugar. All right. So that's the basic stuff. So I thought I'd throw your algorithms at real shit that we're going to be throwing this stuff at. I gave you text because it's very easy. It was an easy thing. It's a white background with block text. A canny image allows you to pick stuff out. This is the kind of shit we're going to be doing in real life. So the next week, your algorithms, by the end of next week, if you guys are any good, you'll have it working on this stuff. And it's actually not that difficult to make it work. And I'll take you through on Monday some methods for doing that. So you guys did not pass that test. That was Team Charlie. Sugar didn't work either. Bravo. That's nice. You caught some horizontal lines. Couple. So this is where I talked about the other week that we can't count on exactly horizontal stuff. You got stuff written on papyrus by hand. It's chiseled into stone. Things curve up. They curve down. So we'll modify our algorithms to take this into account. So by the end of next week, each of these individual lines will be separated into areas if we just make a few modifications to how things work. So I have to modify my algorithm a little bit. My column cutting logic was cutting columns between some of the words that were actually spaced too far apart. That's not necessarily a bad thing. It's worse to miss areas than it is to put a few extra in, as long as they aren't unnecessary. But even here, you can see there are a couple areas that, above and below that shouldn't have been there. Doing it pretty well here. I got some border shit that went on, but I think I cut each of the rows. I didn't finish. I was going to go through and make one more pass to shorten up rows or areas that had white space in them. So this is Bravo. You guys chopped it? Shouldn't chop it. It's one solid thing. So you should have a result like that, and it's pretty easy. It should be pretty easy to fix in your algorithm. Mine did pretty good when things were straight, and then the algorithm kind of freaks out because it does different things. But I know exactly where my algorithm I need to make a change, because I can go back to, like I told you guys, where I keep multiple versions of the algorithms. I can test them with the arguments that are passed in. The first version, earlier version than this, would just encapsulate the whole thing as a single area. So I know that going back into my code, all I need to do is modify my row cutting logic to adjust for rows that aren't exactly horizontal. So, all right, so I'll need to take a look at this, because you guys both had a couple. You both did a very good job. I'm very impressed, actually, because you guys have only been here for like 2 weeks. So nice job. This is a huge project. The modifying the code to work with curve stuff is probably the last piece that we'll do on area detection. It is the most complex, other than glyph detection, like I mentioned. And the reason glyph detection is difficult is we have to figure out how to use other people's systems, and they're not necessarily going to be easy. So once we get through this, we'll have accomplished a huge portion of this project. We're not going to worry about images that have some horizontal, some vertical shit. That's real world, but processing that is going to be a nightmare with our current algorithms. There's another way to approach it, and we'll hit that later on down the road after we do glyph detection. So I think you guys are pretty close. Is anybody, who do you think won, Nikki?
Yeah, probably.
Probably Bravo? That's kind of what I'm thinking too right now.
I would vote for Bravo.
Yeah, it was really close. So you guys you guys did a really good job. All right, I'll take you through the basics of how my algorithm works. I'm not going to break up any code. I'm just going to talk about it on an image here. Let me pick an image. Pick Dilbert. And then what I'd like is at least one person from each team to kind of come up here. We'll take an image of what you got up here, kind of just roughly explain how your algorithm works. Mine works top to bottom, left to right. It passes all the white space. As soon as it hits a feature, a black spot, it's going to start an area, and it's going to continue until it hits white space, and then it's going to stop right here, and that's going to move down. Now, I work through that loop recursively because I know that there's other stuff over here that I missed. I stopped right here on the first pass, so I keep looping through until I know that I've scanned the entire image left to right, top to bottom. And that allows you to separate areas like page number and whatever that thing is separately. I do actually about 4 different passes through my code. First thing does basic area detection, and then I do row splitting. So here you can see the yellow and pink lines were actually originally detected as one big area because the text was too close and there wasn't enough separation of white space. But a second pass through that allows me to cut rows based on density of pixels So I talked with both teams about that, how to go about approaching that, so you guys already understand that. I then make one final pass and cut columns again. So this is where Dilbert comes into play, where if you, initially the algorithms sliced off this whole thing as an area, and then I got it better and it said this is an area, that second section is an area, and the third one's an area. But when I started to cut rows and detect text, it would take that line all the way across. I wanted to cut columns again. So I run the column cutting logic again on the areas to get actually the breaks right here. And one of the things that we could probably change in some of your guys' algorithms is actually throwing out areas that are too small. So I discard areas that are too small because the algorithm picks them up. We can discard them. So that's the basics of how mine works. So who wants to get up and demo, preview their stuff?
I'll go first.
All right, so let me bring up. Oh no, just go through one. It's just a rough, how do you do it? So.
Going with columns. So like that one. Yeah.
All right. Just one person. If you want multiple people to.
Hayden, if you want to do it instead.
Yeah, go ahead, Matt.
So basically ours works. So we have our algorithms for finding rows and finding columns are virtually separate. There's one piece of information that we use finding columns from the rows, which is like the average distance between the rows to tell how far to go down to look for a full column. But that could easily be changed to be just a percentage of the image height. So they're virtually independent. So, but we do go through the rows first, and basically we go through from left to right, top to bottom.
Left to right, top to bottom.
Left to right, top to bottom. No, we go top to we go down this way, and then we look at every row first.
Yeah.
And then we record when we hit a black pixel, and we mark that spot, and we give it we give the box a buffer of like 3 pixels, so that when we find like this over here for this very first black pixel up here, it goes like up or out left 3 and then up 3, and records that point. We keep going, and we record like the furthest left and furthest right and most far down and up pixels until we like get to the end, until we detect a line of just continuous white space, and then we say, okay, that was probably a row. This is like the first pass before we come back to split rows on density. And then we record the points at the other end and put it together into a box. So that would give us like the entire line this before columns. That's basically how our row finding works in kind of a summarized manner. When we come back to find columns, we start from the right-hand side, because we know that at least with English text, the left-hand side of columns is going to likely be a lot straighter than the right-hand sides of columns. Because what we do is we go from the right side and we go top to bottom when we try to find the columns, because we're looking for more continuous white space at that point. And then when we record 2 points. If we hit the bottom of the page before marking a point at a black pixel, then we record that point, the bottom of the page, or enough black pixels, like if there was a paragraph underneath where the column is that doesn't need a column cut through it. And then we record that point, and then we keep going until we hit black pixels, which would be like here. So like this is a column that gets picked up by our column detection algorithm. So it comes down on the right side first, hits this point, and we don't have another one set yet, so it says, okay, that's going to be my first point for now. And then it keeps going, and then doesn't record the bottommost points anymore because we already have one set, until it finds a black point, at which point it backs up, scans again down to make sure that there isn't anything else down there, so that we actually have like a nice clean row again, and then sets another point on the same y-axis as the first point, and then goes back up to the top and sets another one there, and then that's how we find columns throughout text like this. So that also will need to be tweaked a little bit when we do like finding, this should be made to go up until there's more text above it instead of till the top of the image. But that can be a tweak for going on further. And then we basically just take the columns that the algorithm finds as an array, because it just returns a bunch of points, and then we take the rows that were found and we shove them into another function that cuts the rows based on the columns and returns them, and then ta-da. So
Then we also go through and clean up all the super small boxes
Yeah.
and all ones.
Yeah.
once we have our like final array of row boxes, whatever you want to call them, we go through it and we clean out ones. We called it culling them. That's what we have in the comments. We cull the boxes, and we cull them based on whether or not they are, if the area of the actual box is smaller than like some percentage of the image area, and if the width is smaller than some percentage of, it's all based on percentages so that it should be relatively scalable instead of just looking for images roughly this size. But
Nice.
yeah.
Yeah. It's nice that you guys did a nice job. That's one thing I didn't do. I remember talking with you guys or maybe the other team about making it based on a percentage of the page, which is, I need to go back and do that for mine, some of my hard-coded values too. Nice job. Charlie, we'll switch over to some image.
Well, maybe we'll use this one actually.
Yeah, use theirs.
I'll switch to yours.
I think that's mine. Yeah, switch back to a different tab. Yeah.
That's the same one that I was just doing, but I don't know which one of your algorithms it is.
We have the page.
That's the one that I just did.
Yeah. Oh, we didn't do the page.
Oh, I know what you're talking
Page
about.
break.
Yeah,
Yeah.
I skipped that one, yeah. The big page, the gray
With the
one.
number on the bottom.
Oh, I didn't run your algorithm on that?
There was one extra thing that you sent us.
Do you want me to
the
run it
test
on?
one.
Oh,
You
okay.
missed them, I think.
What?
Do you want me to run it out or just talk about different one?
No, go ahead. You can talk about whichever image you want.
Okay, so essentially what ours does is roughly the same as Ethan and Bravo Team's algorithm. We start top down and going right to then left to right. So we find some text, and if it's black text, we draw a box until we stop seeing black text for an image buffer of black pixels, which would be show up as this area will show up as black pixels in a can image. So we have a buffer of that set up to the image width, a percentage of the image width. And so essentially we keep going until we see a large pixel of white. So usually that grabs the whole line of text, and we call that data 0. So we essentially have 4 different data that we can return based on which algorithm you select. So at the end of our algorithm essentially is supposed to pick the best data set out of each of them. So I'll kind of explain what the different data work. So data 1 is just supposed to be this big line. Data 2 is supposed to go through each of these lines and draw density lines depending on how many black pixels are in an image. So if there's like, I don't know, 78 Gs down here, the density below where the Gs are, it should be higher, so it should move the box down below to there. Or up above to there if there's only 1 G. So that's how we separate it instead of getting big blocks of text with a bunch of overlapping text down here. So if a G comes down and we have like 3 capital T's or something, it might catch that and condense it into one box. So we didn't want that, so that was the purpose of the density array. So at that point we had our boxes pretty much all cut into individual lines for the most part. Some cases it didn't work, and then so from there we ran our column calculating algorithm on it. But the way our columns work right now is it starts at the left pixel, so if there's any black pixel on the edge of a page, like, I don't know, the edge of a page or something, like, I don't know, hard to explain, but, so if it sees any black text, it goes from the first big indice of black text in a row. So it'll draw a column until it stops seeing black text. And so that's what you're seeing over here. You got a 1 pixel black speck over there, so that just completely destroys the algorithm. So, but we know how to fix that. So from there on, so that's kind of how you see, like some of these, there's no black text on the left edge here, so it is cutting the column right. So that would be data 3. So then after that, we have data 0, 1, 2, and 3. And our algorithm goes through and it does box, it calculates the number of white pixels in each box, and it takes that and finds the ratio of pixels to boxes, and then takes the one with the highest pixel to box ratio, and it's supposed to pick that algorithm and return that array. So that's kind of what I was thinking we would do, or we were going to do in the vast sense. So we all run, like if we have 4 algorithms, we run them all, and then we calculate that area based on the image, the number of black pixels per box, and we return that image, because those should be the tightest.
Nice. So, I mean, it's fairly easy to modify this throughout the small areas. You might, it looks like you're adding like a padding a little bit around some of the boxes, or at least you were with your sugar, I think it was your sugar algorithm. But, before you add padding to areas, that's where I do the culling, like toss some things out. You know, evaluate the areas by size before you add any extra padding. One thing you guys might want to do to this algorithm too as well before we move into next week, or at the start of next week you can do this. And Bravo, you might want to adjust your column thing too. What I would do at the end or close to the end of your current processing is loop through all the areas that have been detected and run a column detection on each of those areas and break them apart. So that would doing that with this algorithm would very easily split the columns. You can try to do a column break right away, which is what I think what you guys are doing. You're trying to detect that first off, but it's not gonna. There was another sample image that the reason I do column breaks twice is there's an image that once you see it, you know it's not gonna. You're gonna have problems with it, and I'll show you what it is. And this is. It would be a fairly common type of image that we would get. Let's see, harder. Medium. This guy right here. So really what you want to do is you want to isolate each row, and you might detect this as a row initially in that, but you want to cut columns in here because you want to separate this. This is not part of a row. So rows actually would start in here and out there, and the only way to get this is if you run a column algorithm, you know, after you've already detected that row. Does that make sense? So you can probably, a lot of the code that you have in your current code, I would create a new function that just says, you know, call it, you know, the column cutter or whatever you want, and allow it to just, you pass it, you know, an array. And so at the top, in your code, you just loop through all the areas that you have and cut columns in each area. And then it might split them into 2 or 3 or 4 different areas. So, all right, nice job, everybody. Did a good job.
Can I ask some questions?
Yeah.
So, watching the whole thing from the beginning, I was like doing a whole bunch of whiteboard shit in my head and like thinking about it. Do any of you guys know C or C++? Yeah. Okay. Do you know how the preprocessor works? Like when it's expanding macros? And any programming language in general, actually, it tokenizes everything. So like it takes the entire thing and breaks it into tokens, right? And then it goes over it again and it breaks it into tokens, and it goes over it again and it breaks it into tokens. And only until all of those are expanded does it actually start doing compilation or interpreting, right? And like the whiteboarding that I was doing in my head for that is the giant recursive thing, right? Is going over and marking giant spots as dark or not, and then going back over it and retokenizing those into small little tiny spots. And then once you're done comparing those two things, the overbounding, I don't know, I haven't seen any of it, but I think that would be helpful to think of them in areas as like tokens, right? I'd have to look at the code, but it seems easy, kind of. Maybe not. Maybe they're just bullshit.
I think there's something to that. I kind of had an idea on how maybe we would detect columns better of just making broader boxes and then running the columns again through the boxes individually instead of running the columns on the entire image. And then maybe that would reduce the need to even cut columns or define them if you can just make squares around the text.
The entire image first and then the individual boxes.
Yeah.
Just to catch those little.
Yeah, you might want to do it more times than once, and the reason for that is you can't choose to cut columns once and rows once because it'll screw you on things like this. So this you need to cut columns first, and then split rows, then cut columns again if you want to get to the inner portions of an image. You have to do it at least twice. You might need to do it more depending on the complexity of the image, but you know we're not going to do super crazy stuff. I think that the image I showed you where there's something right in the middle of a line of text is about as complex as we want to get for that stuff. So, all right.
Brian, for your method, were you trying to get it all the way down to letters then?
I haven't done anything. I'm just talking. I mean, like the first I've seen is this. It's just thinking out loud, right? Like taking my craziness and putting it out here. Like I can.
Don't infect my team with your crazy.
I'll try not to. I do want to do code reviews when it's over. I'd like to look at it and see it if you guys have time for that. I don't know what the shift for the rest of the day is.
Yeah, we got time. Well, officially in Wisconsin at 2 p.m. we switch over to video game time, so you got a half an hour. before, did you get that Halo 3 working? No. So you've got a job to do in the next 30 minutes, or we got to switch over to PS4. I think that's pretty much it. So Monday, we'll go through some methods for adjusting your algorithms to take into consideration lines of text or rows of hieroglyphics that curve off a little bit, because that's going to be our next thing. I'd like us to get to a point where we have that finished by the end of next week. So I think Bravo team was the winner here. It's close, but like you guys, I was so confident. You guys came across as so confident the other day on the way out. You wanted to call Showdown on Wednesday.
To be fair, if they did, they probably would have won.
That's
Right?
ours
wasn't done then.
We made most of our breakthroughs.
Well, this is. I mean, it is. You still have to. What I did say, you could call it early, but you still have to pass all the tests. So you wouldn't have, if it was operating like that, you wouldn't have passed all the tests because you weren't cutting all the rows, you weren't detecting all of them. So you missed some there. So
We can just thank you for giving us a week.
yeah.
Because we've had a lot of obstacles, but I think that.
I didn't think you guys were going to come up because yesterday you just said I had a breakthrough or something at the last minute. It's like it's only one day to change all your code.
But it was kind of one of our last issues with columns.
Well,
Okay.
Yeah, and like yesterday, was it like yesterday morning that I finally did that?
Yeah, it was yesterday
Yeah, we
morning.
finally got columns to work.
Yeah, basically the whole rest of the day yesterday was just like, we had the row cutter, we had the column cutter, and it was just like getting them to actually work and make sure they return the right data running on the server too, and then splice them together. And
A lot of playing
Yeah.
with it.
Okay.
Isn't that how it usually works, though? I mean, when you have your aha moment, and then everything really comes
Yeah.
together quite quickly thereafter.
That's what it felt like, yeah.
Well, we were pretty confident. I mean, prior to today, we had like 3 individual algorithms. I mean, we must have misinterpreted the directions or anything. But like,
So you guys would have chosen a different algorithm based on the image that came in.
per scenario.
Not necessarily even per image, but for column examples, we had a columns that
Yeah.
ran columns confidently, like for all of them.
Yeah.
And then for plain text, we ran plain text and it cut all the lines.
Yeah, I probably didn't explicitly state that, probably because I didn't even think about it.
Clarified too,
'Cause it's just-
does the user have to specify?
Yeah, I mean the problem is we're gonna, for some stuff, we're going to have to say, okay, we're uploading a photo. Is it a manuscript or book, or is it like on papyrus or like in stone? And probably the second thing we need to ask them is it vertically aligned or horizontally? It's gonna make a huge difference. Our algorithms right now will fail miserably on things that are actually in columns and with hieroglyphic style. We're gonna have to do a 90-degree rotation, run our algorithms on them, and then adjust all the coordinates, because I see that as being the easiest way to do it. Okay, so next week we'll we'll adjust these a little bit. I'd say there's a little bit of cleanup. Charlie, get rid of the dinky areas, throw them out. We don't want them. We don't even want to consider them, because if you don't get rid of those, we can't use your algorithm moving forward. So I would probably adjust your code to run the column cutter on the existing areas to clean that up, because you're going to need it to work better. These are super simple examples, and if you're not doing that, it's going to fail on anything complex that we have. Next Monday, I'll take you through methods for when you're doing the row scanning and adjusting for a nonlinear line. And so we'll make adjustments with that. After we accomplish that, we're going to come back. We're going to still be dealing with areas. But so my goal is at least my algorithm's going to work, because I'm going to fucking make it work. If it takes me a week, it's gonna work. And at least one of your team's algorithms is going to be a finalist. Hopefully both of them. Because what we're going to do in the system, when somebody wants something decoded, like I said, we're going to launch 2 or 3 algorithms at it. Each algorithm is going to come back with its own specific result set, different areas. So the next algo worker that we write is going to take n number of results from different workers and put them all together, and it's going to say if one algorithm found an area that another one didn't, include that. It's going to get rid of the duplicates. It's not as easy as it sounds, because each of the areas slightly overlap. It's not going to be, we're going to have to actually go on the whiteboard and figure out all the different things that can happen. What do we want to do? Do we want to condense areas? If one algorithm says it's a big area and another one says it's smaller areas that make up that, we need to make a decision how to do that. But that'll be our next thing. And after we get that done with that, that's when we move on to glyph image stuff. So that's That's what we have left. Nice job, guys. Thank you.